Okay, so in the previous example, we've seen why we needed dot product. So I had introduced the whole problem of finding the work done in case when we have two vectors. So I'll just read out that thing. Two vectors. This is the force vector. This is the displacement vector, and the force vector was represented by 2 I cap, which means 2 I cap in this direction, this component, and so I'll just change the numbers. I forgot the numbers. Okay, in the previous example. So let's say 2 I cap and 3 J cap. So I've just changed the numbers. I don't remember what was the previous example. Okay, and let's say I have 5 I cap plus 1 J cap. So here, okay, so this is my displacement vector here. This is my force vector. So I'll just write it force and displacement. Sorry for the bad handwriting. Okay, yeah. So this is my force vector. This is my displacement vector. And now I have to find. So what is dot product? So dot product was. Let's change the marker. So what is dot product? Dot product was A dot B. So if I had to find the dot product, okay, as work is the dot product of force and displacement, right? So what is dot product formula? A dot B equals A times B times the cos of the angle between the two. Okay, and now I have to find this, but here I have been given a completely different form of vectors. Okay, I have not been given the magnitude. I don't have the angle between the two. How do I find this? So let us, okay, I'll write work. Okay, so let us start by finding work. So A dot B is work here. Okay, so I'm trying to find work. Work equals force. So the magnitude of force, okay, multiplied by the displacement. So multiplied by displacement and multiplied by the cos of the angle between the two. Okay, so that is the that is what we have to that is our starting point. Okay, what we're trying to find out is work here. So work again equals force. So what is force in this case? Force is given by this, but I can simply plug in this, right? I have to find the magnitude of force. What is the magnitude of force? So how to find the magnitude of a vector given this in this form? So I hope, so this is 2 right here. This component of the force is 2. So if I draw it, I'll draw it here quickly. This is my this is the same vector, okay, here drawn here. So this component is 2 I cap and this component is 3 J cap. J cap means in this direction, I cap in this direction. So how do I find the magnitude? I use the Pythagoras theorem. So this is equal to this, right? So this is also 3 J cap. So how do I find this? Well, I find the length of this vector by simply using the Pythagoras theorem. 2 square plus 3 square whole under root, right? So that is a simple way. Now whenever we are deriving a formula for something, we don't work with numbers. So here I've written numbers, but this won't help me much. If I work with variables, I'll actually end up getting a formula which I can use everywhere by plugging the values, okay, there. So now without taking any more numbers, I'll actually start using variables instead. Okay, so let us take a general case, and the variable that I use will be, so let's say the force is x1 I cap plus y1 j cap, and displacement here is x2 I cap plus y2 j cap. Okay, clear? So these are my two vectors in general form, force vector, displacement vector. Now what is the magnitude of the force vector? So first we find this, which will be x1 square plus y1 square, okay, and whole under root, right? So this is my force vector, and I can similarly find my displacement vector also, the magnitude of the displacement vector, which will be x2 square plus y2 square whole under root. Okay, so this is how we use our Pythagoras theorem, right? A square plus b square, a square plus b square whole under root. So I've got the magnitude of the two vectors. Now multiply this by the cos of the angle between the two. This is what will actually cause the problem, whole problem. Why? I've got the force, I've got the displacement, but how do I calculate cos theta? To calculate cos theta, I need to know theta, but I don't have any theta here. But obviously, I'll have to use some trick to find out theta here. So yeah, let us continue to the next video. Until then, you should also try and think of some way of finding theta. So is there any way by which we can actually calculate theta? If not theta, then can we in any way calculate cos theta here? So yeah, let us continue in the next video, and there we'll see how we actually calculate cos theta. Bye.